So we are continuing our lesson on understanding slope and y-intercept with topic 8, block 4. And let's take a look at this graph, which is an extended scatter plot. It's a scatter plot because it has individual dots rather than the solid line. Now, let's take a look at this question. The question asks, how many caps do they need to sell before the club starts to make a profit? Okay, so you can see the blue line is the number of caps ordered and the cost projection. And then the number of caps sold starts down here and the projection of money that they're taking in. Now, the great thing about having these two lines that we can compare is that when they intersect, is it possible, can anybody tell me what the intersection of those points will tell us? So when these two lines intersect right here at that point, that tells us that's when they break even. That's exactly right. That's when their cost and the amount of money that they're taking in is exactly the same. So in order for them to make a profit, how many caps are they going to need to sell? So if let me erase my little circle that I made there. How many caps will they need to sell in order to start making a profit? So something you might want to take a look at is, while we're doing this, yes, someone has their hand raised. Go ahead.
Oh, I want to see the answer for how many caps they would need.
Yes, go ahead.
They would need to sell 16 caps.
You're absolutely right, because 16 caps puts us right here, which is just beyond the break-even point. So in order to start making a profit, they would have to sell indeed 16 caps. Does anybody have any questions about that? Feel free to type it in the chat if you need to. I don't see anything happening in there. Remember, if you have a question, you can certainly just type a question mark, and I will wait for the question to be typed fully. All right. So that's the nice thing about these types of graphs, is that you can compare the data and see and answer specific questions about real life situations such as this. Now, taking a look at this, question number 6, which line on the graph is steeper? Caps sold or caps ordered? All right, thank you for that. Yeah, caps sold is steeper. And so it's easy to see that right here, that line is definitely steeper than the caps ordered. So why is the line steeper? What about the rate of change tells us that that would be? What information do we have that tells us that line is going to be steeper? I guess that's the question I need to ask. Remember, you have to look at the rate of change. The rate of change for caps ordered is only $3.50, right? Every time they order another cap, it's $3.50, $3.50. That's not a lot compared to every time they sell a cap, they make $10. So the rate of change for caps sold is $10, whereas the rate of change for the caps ordered is only $3.50 per cap. Each of those is per cap. Okay. So which line on the graph is steeper? Well, that's caps sold, of course. And it's because the rate of change, or the slope, right, is $10 compared to $3.50 for the number of caps ordered. All right, so looking at this, what is the y-intercept of each line that we graphed in question 4? So caps ordered Caps ordered. The y-intercept is how much? What's the y-intercept? Where does it cross the y-axis? Anybody tell me in the chat, where does the caps ordered cross the y-axis? At what point? Nobody bold or brave in there to tell me where the y-intercept. Remember, the y-intercept is where the line crosses the y-axis. Yes, thank you for that. Somebody typed in at $100, and you can see that right here, right? $100 is where the caps ordered line crosses the y-axis. Okay, so the y-intercept is going to be $100 or 100. And what does that mean? Well, that's the, in this case, that's the startup cost, right? That's where the cost begins at $100, because remember, that was their setup fee. And then the caps sold, the y-intercept, where does that one cross the y-axis? Where does caps sold cross the y-axis? The y-intercept. And that one, yes, thank you. That's at 0, right? The y-intercept is 0 because when it crosses the y-axis, it crosses it right here at 0, 0. And it's because they don't make any money until they start selling caps. So no caps sold means no profit or no money made. Okay. Awesome. Thank you for your contribution to the chat. All right. Now for this one, looking at question number 8. For each data set, we're going to find the quotient of the amount paid or collected and the number of caps. Okay. So, and the number of caps, let me put that in a different color. Number of caps. So here's the number of caps, right? And then highlight the amount paid versus the amount collected. So we are going to find the quotient of those for each one. Okay, so what are we noticing if we're looking at that? Well, so let's take, first of all, in the table on the left, the number of caps ordered versus the amount paid. 100 divided by 0. What is 100 divided by 0? Remember, the amount paid or the amount collected. 100 divided by 0. Let's see. Of course, that's 0. What did we expect it to be, right? Okay, well, let's take a look at the next one. $103.50 divided by 1. Well, we know that one, right? It's going to be $103.50. Now let's try one more. How about 107 divided by 2? 107 divided by 2. 107 divided by 2 is 53 and a half, 53.5. Okay, and so that's probably enough for the other side. Let's go to the other side of the equation, or the other table, and look at that one. Starting off with the first one, of course, 0 divided by 0. Well, that's going to be 0, but let's go on from there. How about 10 divided by 1? That's 10, right? 20 divided by 2 is 10. 30 divided by 3 is 10. So notice here that when we, I guess I should put it, when we divide for the table that's on the right here, the amount collected divided by the number of caps sold, we get the same result every time, right? We get 10, 10, 10, with the exception of the first one, of course. That's our exception. But on the other side, we could keep going. Let's try 110.50, $110.50. We're going to divide that by 3. And what do we get for that one? 110 divided, or sorry, $110.50 divided by 3, 36.83. So what are we noticing here? Does anybody notice something about the quotients from the one side versus the quotients on the others? What you should begin to notice is that on the table on the right, the number of caps sold versus the amount collected, that when we divide the amount collected by the number of caps sold, we get a constant rate of 10, 10, 10. But on the other side, when we divide the amount paid versus the number of caps ordered, we do not get a constant amount. That quotient ends up being different every time. 103.5, 53.5, 36.83. So they're definitely not the same. They won't have that same constant of proportionality. So let's talk about question number 9 coming off of that. It says, what is a proportional linear relationship and how can you identify it? All right. How do you know if you have a proportional relationship? Anybody want to have a go at that one? What is a proportional relationship and how can you identify it? What does it mean for a quantity to vary directly with another quantity? Okay. There are equal proportions of a number. Okay. So when we look at something such as this, when we divide the amount collected versus the number of caps sold versus the amount paid versus the number of caps ordered, one of these has a proportional linear relationship and one of them does not. And of course, I can tell you that if we have a proportional relationship, it's going to be the one on the right. Yes, this side over here is the one that is proportional. And that's because when we divide, with the exception of the 0, when we divide our y by our x, every time we will get a constant, and I'll use a k, we will get a constant number every time. All right? So y divided by x will give us a constant, the same quotient every time, the constant of proportionality, heretofore always to be known as the COP, constant of proportionality. So when you divide y by x, you'll get that constant. And if we were to graph this, it will look like the graph that we had where the line passes through the origin at 0, 0. When it's 0, it will always go through 0, and there will be a constant of proportionality. And so that's why when we look at this, there's the 0, 0. That's how we know if it passes through there, it will be a constant. And also when we divide y by x, we'll always get that same constant. Now notice on the one on the left, it does not pass through 0, 0. The y-intercept is 0, 100. And we also do not have the same value when we divide our y by our x. Okay, so always remember, so these are the things that we look for when we want to talk about a proportional linear relationship, okay? The proportional linear relationship, the qualifiers. The line passes through the origin at 0, 0. All right. And when you divide y by x, you always get that constant of proportionality. And in a table, if you were to create a table of your x and your y values, it will also be 0, 0 there. Okay? Any questions about that before I move on? That's an important thing to remember. Remember, just type a question mark in there if you have a question. Okay, well, as you can see, I'm slowly moving on. All right, well, let's take a look at this. These are two different tables. Let's consider these two different tables. Is the data in the table proportional? Okay, remember, for it to be proportional, you divide your y by your x, and you're going to get a constant number every time. So in this case, if we divide 5 by 1, what is that? 5 divided by 1 is 5, correct? Yes. Here, if we divide y by x, remember, y divided by x. If here, 6 divided by 2, well, 6 divided by 2 is 3. 7 divided by 3, well, that's not going to work out, is 2.33333. Repeating. And 8 divided by 4 is 2. Is this a constant? Is this a proportional relationship between x and y? Absolutely not. No, because we do not have, thank you. Yes, thank you. We do not have a constant of proportionality, right? Let's take a look at the next batch here. How about when we divide, remember, we are dividing y by x. So this would be 12 divided by 4, that's 3. 18 divided by 6, that's 3. 24 divided by 8, that's 3. This is looking pretty good. 36 divided by 12, that's 3. We have, does y divided by x give us a constant? Yes, it does. So that means that we have a proportional relationship here. Because when you divide y by x, if you get the same number every time, the quotient is the same, you have a proportional relationship. All right. Well, we are out of time, and that's the end of the problems that we would normally be doing together. I will put together the rest of the assignment to make sure that you get it before the end of the day. Have a great rest of your day. My time is up. Don't forget to be awesome, and I will see you later.